Today's topic is two-port networks. We are going to see what is a two-port network and what are the different parameters, types of two-port networks, and an example in Z and Y parameter. Let us look the definition of a network. A network are of two types, one port and two port. A single port network is a pair of terminals where the current enters one terminal and leaves the other terminal. It's said to be a single port. So our aim is we want to know about the two port networks. Let's get into it. All the electrical networks comes under two port network. It will be having an input port where the input current enters and the input current comes out, and the output port. So why we study a two port network? So every system, like a communication system, a control system, power systems, they all comes under two port networks. So the best example will be your electronic system, which you have studied already about a voltage regulator in electronic circuits. So this block diagram is much familiar to you people. So this system is a best example of two port network. Take the transformer block. The input is given and we take the output. See the waveform? The peak value is reduced. Then bridge rectifier. The bridge rectifier will convert your sinusoidal wave into a unidirectional one. So input is given as your AC signal and the output is your unidirectional. Again, it's a two-port network. Filters same. So it's going to remove the ripples from it, the unwanted AC signal. So input is given as your unidirectional signal, which filters and gives you a ripple-free signal. So each of the block is a two-port network. So now it's clear to you what is a two-port network and why we study here. So two-port networks are driven in the sense they are supported either with a voltage source or a current source. So what reasons we study a two-port network? So irrespective of what type of systems, if we want to know the relationship between the voltage and a current in that system, we need to know the parameters. The voltage and current are interrelated. So if we come to know them, it's easier to design a system. So the network parameters are nothing but it gives you a relationship between the voltage and current of the system which is going to be designed. So the two parameters we are going to look into this lecture is the Z parameter, Y parameter. Apart from that, we have hybrid parameters, ABCD parameter, T parameter, etc. So what does a Z parameter says? It is also said to be known as impedance parameter, and it is commonly used to synthesize the filter. And the best example of impedance parameter is impedance matching in the transmission lines or power distribution networks. Okay, let us see the Z parameter circuit. So at the input port we have these parameter values and at the output port. So the Z parameter is being related by these two equations. V1 is the input voltage and V2 is your output voltage. And we can write this in a form of a matrix also. So our aim is to find the parameters Z11, Z12, Z21 and Z22. So to calculate the Z11, which are said to be known as the input parameters, we have to make open circuit the output port. So if the output port is open circuited, I2 will be equal to 0. So if I2 is 0 in the first equation, then our Z11 will become V1 by I1. If I2 is 0 in the second equation, then we'll get Z21 is equal to V2 by I1. So to find the output side parameters Z12 and Z22, we should make the V1, the input voltage, to be open circuited. So when it is open circuited, the current I1 will be 0. So when the current I1 is 0 in the first equation, we'll get Z12 is going to be V1 by I2. And if I1 is 0 in the second equation, we'll get Z22 is equal to V2 by I2. So let us have a look. So Z11 is to be the open circuit input impedance. Open circuit transfer from, yeah. So in impedance parameter model, we have to a reciprocal network. Reciprocal network is a network where our Z12 and Z21 will be equal. If our Z12 and Z21 are equal, we said to be a reciprocal network. So our network will look like a T section. Now the non-reciprocal network, and Z network is said to be non-reciprocal if Z12 and Z21 values are different. So this network is said to be a non-reciprocal network. Now let us see how to solve the problem of a Z parameter in the next video. Thanks for watching.
In y parameter can also be defined as y is equal to z inverse. And in this y parameter, I1, I2 are the dependent variable, while V1, V2 are the independent variable. So we can represent any kind of network in y parameter. I1 is equal to y11 V1 plus y12 V2. Similarly, I2 is equal to y21 V1 plus y22 V2. So this is exactly opposite to the z parameter. So in matrix way, we can define I1, I2 like this. Okay, now it is also known as short circuit parameter. Why it is known as short circuit parameter? Suppose you have to calculate the y11. So in order to calculate the y11, you have to make v2 is equal to 0. If you will make v2 is equal to 0, then y11 you will get I1 upon v1. So how will you make v2 is equal to 0? By short circuiting this secondary port. So if you will short circuit this port, then you can easily calculate y11. Now to calculate y12, you have to make v1 is equal to 0. So short circuit this input port, you will get y12, that is equal to I1 upon v2. So in order to find the y11, y12, y21, y22, we have to short circuit the input and output terminal. That's why it is also known as parameter. So if I have to calculate the y11, then I can easily calculate y11 is equal to I1 upon v1 when v2 is equal to 0. So in order to calculate y11, I have to short circuit this v2 terminal. If I will short circuit this V2 terminal, then this admittance is of no use. Like if I will short circuit this V2 terminal, then the circuit will become like this is YA, this is YC, and this is short circuited. Okay, this is short circuited, so YB of no use. This is I1 and this is V1, this V2 is 0. Now apply nodal equation here. You will get minus I1 plus V1 YA plus V1 YC. So I1 upon V1 is equal to YA plus YC. In this way you can find by short circuiting input and output terminal in order to find the different Y. Let us see. We have V1 is equal to Z11 I1 plus Z12 I2. We have to find Z11, Z12, Z21 and Z22. Okay. So first method I have already explained you by using KVL. The second method is the open circuiting method. Means if I have to find the Z11, if I will make I2 is equal to 0, then I will get Z11 is equal to V1 upon I1. So now make I2 is equal to 0 and this is open circuited, means ZV is of no value. So overall circuit will look like this, right? This is V1, this is I1, and since the current flowing in this outer side I2 is equal to 0, so there will be no I2 current flowing in ZC. So overall you will get I1 current from ZA and ZC. Now find V1 upon I1, you will get ZA plus ZC. In this way you can find all the parameters. Like if you want to find Z12, Z12 is nothing but V1 upon I2 when I1 is equal to 0. If I will put I1 is equal to 0, then Z12 is equal to V1 upon I2. Put I1 is equal to 0 here. Okay. Now find Z12. Z12 that is equal to V1 upon I2. I2 is flowing. The circuit will look like I1, since I1 is 0. So I am not considering any drop here. I am getting only ZC. Okay. And this is ZB. I2 is flowing like this and coming like this. Since the current flowing in this ZA I1 is 0, so overall I2 will flow in the ZC. Now you have to find V1 upon I2. Apply KVL here. Since there is no drop across ZA, so V1 is equal to I2 ZC. So V1 upon I2 is equal to ZC, that is equal to Z12. In this way we can find all the Z parameters by open circuiting the input or the output terminal. Okay, so finally I will get Z11 is equal to ZA plus ZC and Z22 is equal to ZB plus ZC. Similarly